Example 10. The demand for a product is given by d of x equals 130 e to the negative 0.4x, where x is the number of units sold each week and between 0 and 60, and both of those are included. Step 1 is to find the number of units sold to maximize the revenue. Round your answer to the nearest whole unit. So I'm going to take the derivative and I'm going to see if there are any critical numbers, and if there are, I'm going to check the critical number and both endpoints to see where the maximum occurs. Now, I don't really have to do the test for maximum on this because I know that it's going to be a maximum just by the fact that they've told me that it's going to be a maximum. So what we have to do is find the derivative of the revenue. Now, here's where it gets tricky. When they're talking about revenue, that's going to be demand times x, or x times d of x, or d of x times x. You have to remember to multiply this whole thing by x. So my revenue, this is step 1, my revenue of x is d of x times x, or x times d of x, it doesn't matter, 130 e to the negative 0.04 x times x, and this makes it a product rule. Okay, and you got two functions in x. I think I'll move my x up here to the front and take it with the 130, right? So that's going to be my first function. And my second function is going to be the e function. So even though it's a product rule, it should be pretty easy. My first function is 130x. My second function is e to the negative 0.04x. So f prime, first function's derivative is 130, and the second function's derivative is negative 0.04 e to the negative 0.04x. So by now, hopefully you recognize that when you do an e function, it's e to the x times the derivative of the exponent, which in this case was negative 0.4. So labeling this as r prime of x, I'm going to do first derivative second plus second derivative first. So 130x times, and I'm going to use the parentheses for my times. Let's see, that's negative 0.04 e to the negative 0.04x plus the second. Give me a little more space. So my second was, let's see, e to the negative 0.04x, derivative of the first, which was 130. Now I'm going to clean this up a little bit. I notice they both have 130 as coefficients. And let's see, so I'm going to factor out that 130, and they both have this e factor as well. Look, they both have this. They both have 130. Okay. So look, this one has an x and a negative 0.4. So I'm factoring out 130 e to the negative 0.04x. This first one has an x remaining and a negative 0.4. So negative 0.04x plus, and when the entire thing factors out, I need a 1 because 130 into that's e to the negative 0.4x is going to be 1. Now I have two factors set equal to 0. Well, this one is never equal to 0. An e base is always a positive number. So all I have to do is set this second one equal to 0. Solve it for x, and x comes out to be 25. Notice that 25 is in our given domain between 0 and 60. So I have three numbers to check. I need to check, and remember, I'm checking in the original, so I need to check revenue at 0, revenue at 25, and revenue at 60. All of those will help me find the maximum. So R of 0 is 130 times 0, e to the negative 0.04 times 0. That comes out to be 0. R of 25, and remember I'm checking in revenue, so that's the d of x times x, and I've put the x here, so that's 130x e to the negative 0.04x. That's the revenue function that I'm using. At 25, it's 130 times 25 e to the negative 0.04 times 25. That one comes out to be 1196. And then when I do R of 60, 130 times 60 e to the negative 0.04 times 60 comes out to be approximately 0 again. So this is definitely my maximum. 25 units result in the maximum, and if they ask for the ordered pair, it would be 25, 1196. In this case, they just asked for the number of units. Now, be careful. It is not always the critical number. It can be the endpoint. You must check the endpoint. Okay? Now, the last thing they ask us for in this problem is the price per unit. And remember, price is demand, D of x. So all I have to do for this part 2 is I need to find D of 25. This is going to be the price at max revenue. So that's going to be 130, no x this time, just 130 e to the negative 0.04 times 25, and that comes out to about $47.82 if you do that on your calculator.